radiographic processing review, diagnostic imaging, VTNE, and final exam review. So with our darkroom procedures, whether you are using digital or whether you are using darkroom, we have a few things that we have to keep in mind. We are going to need to take images that come to us from electrons being converted into electromagnetic radiation, and it is going to have to hit the sensor. And as it hits the sensor through our patient in a digital setup, that will either go to a computed radiography process computer system and then go up onto our computer, or in the digital it will receive, convert the information into an image for us on the computer screen. If we are using film, and yes, you still do need to know film for the VTNE, you still need to know film for your final exam. So it is still important. You never know when you're going to find a practice where you have to know film. Once you know the hard stuff, the rest of it is really easy. So we have to take our film, and we have the unexposed film, and I know that that picture is in light, but that is what our film is going to look like. It is typically a very pretty shade of lavender. Inside our cassette, we take our image, and keep in mind that the X-ray film is at its most sensitive after it has been exposed, but before it has been developed. Once we have that, we're going to need to put permanent markings, permanent identification onto that film. Now in digital and computed radiography, it will do that for us, and we can type in what we need to see on there. But in the case of film, as you can see, that little rectangle in that upper left-hand corner of that cassette is a place where we can take that corner of film, stamp it, and have a permanent identification on there. From there, it is going to have the silver halide emulsion that is covering that film. It has been altered or changed after we expose the film, and then we will develop it. And it will change our silver halide crystals into black metallic silver. So anything that has been exposed by radiation will be in various gradients of black and grays. So as you can see on that image on the right-hand side, those lungs have had a full exposure of radiation, and then the tissues and fascia has had various levels of exposure going through it based on the density of our patient. The bone blocks a lot of that radiation, but the tissue, it will pass through, and especially the lungs, which are filled with air, those will show up as black on our X-ray. Then we go from the developer, where we have the black metallic silver, into the fixer. And the fixer will then convert or wash away any unexposed silver halide crystals. So it will stop the developing process, it will work to preserve the film, and it will wash away the unexposed crystals. So the areas there where the ribs are, that area in the center over the heart, that is going to be an area that we had blocking radiation, and so the fixer will wash away those silver halide crystals, and we will get the unexposed portions of our X-ray, or the less exposed portions. So our final image will be black and white image with various shades of gray in the middle, and we get ourselves a good diagnostic image for our veterinarian. Safe lights are another thing that we have to keep in mind in processing. And this is going to give us just enough light to work without fogging up our film. This can still, over time, cause added density into our radiograph. So we want to work quickly and efficiently. We can work with direct or indirect lighting. Direct lighting needs to be 48 inches or 4 feet away from our workspace. And indirect lighting can be mounted closer, but it's going to be facing upwards away from where we're working. So we will get indirect lighting coming from that. The safe light should never exceed 15 watts. With our developer, the optimum temperature is 68 degrees Fahrenheit. If it is hotter than 68 degrees Fahrenheit, it will develop faster. If it is colder than 68 degrees Fahrenheit, it will develop slower. The time needs to be adjusted according to our developer temperature. And the chemicals that is going to change the exposed silver halide crystals in the X-ray film to black metallic silver, and a latent image or a ghost image appears. So as you can see on this little clip right here on the bottom, this little area of film works the same way. And so the darkened sky down there, that's going to be the area that was most exposed or brightest. And so like on our X-ray, that would be the lungs. The lungs would be black. Fixer, on the other hand, the film will stay in the fixer for twice as long as the developing time. So if we are developing, like hand dunking our films, and that takes 5 minutes to develop, then our fixer will be for 10 minutes. It will stop the developing process. It will preserve the film. And the silver halide crystals that are unexposed will then be removed. Some troubleshooting when it comes to processing our radiographs. If we have underexposed, we have not cooked our toast enough. So we could have too low of MAS, too low of KVP. Our focal film distance could be too high, screens could be too slow, or our screens don't match the film. Underdeveloped, not left in the developer long enough. Chemicals could be too cold. The chemicals could be too old, or the chemicals can be exhausted. And so the images on the left-hand side there, underexposed. That top one, the MAS is too low. The bottom one, the KVP is too low. So you can see that MAS is a bigger change than the KVP. KVP is like small steps. MAS is like large jumps. The ideal exposure is in the center down there. And then on the right-hand side, we have X-rays that are overexposed. The MAS is too high, so it's really, really dark with the density. And on the bottom, we have decreased contrast, or our KVP is too high. So we would need to subtract from those numbers to reduce that and get it back to the center image here with our ideal exposure. In this case, we burnt our toast. So we might need to reshoot, and we would need to retake our exposure, reducing the levels of MAS for that top image and KVP for that bottom image to get it closer to the ideal exposure. We would change the density for the MAS or the contrast for the KVP. We change one or the other, but not both. So on the underexposed, we need to add to it. For the overexposed, we need to subtract from it. Other errors, other issues that we can run into when taking our radiograph, if we have black lines, especially in a regular border along one side of the film, that can mean that our cassette is cracked, it's letting light in. It could be exposure from the storage box. Maybe someone turned on the light without closing the films to be used. And then white marks. White marks are often going to be dirt or debris on our screens. It could be contrast medium on the cassette, on the patient, or on the tabletop as well. And so that's vital for us to administer the contrast medium, protecting the animal, protecting our X-ray environment, usually adding it to the animal from another room, keeping our animal wrapped up in blankets or towels as we administer the contrast study. And then we take them into the radiographic area from there. Other things that we can run into, chemical marks. Maybe we set down the film in part of the chemicals that were on our counter or in our workspace, and that can adjust our film, unfortunately, too. We have our whoops ray as well. So, you know, we take an image and someone happens to be touching the animal, then their hand gets exposed, which is, of course, not good. And then the top one there, we could have a blurred image from an animal that moves around too much. Fogging is another one. Fogging is going to be adding a gray appearance or a plus density to our film. The film could be unintentionally exposed to light, to X-rays, to heat, humidity, to chemicals, low-grade light leaks, having someone's cell phone or smartwatch turn on while we're processing our film, or it could be due to excessive scatter. And then we have the linear artifacts, which is grid damage. Remember that the grid is going to be underneath the table. We could have inadequate drying in the processor. The rollers could scratch the emulsion. The rollers could scratch the X-ray afterwards. And then last, we have static electricity. And this is where we can have static electricity that can actually spark and change our film, adding exposure to it. So it looks like a tree pattern, or it can look like linear dots. This can be due to too low of humidity in the area.